My name is Callum Walter. I'm a postdoctoral research scientist working jointly with the U.S. Geologic Survey and NASA Ames Research Center. And my work seeks to develop novel geophysical technologies and surveying methodologies for the detection and characterization of off-world resource deposits.
Welcome to Seismic Sound Off, exploring the depth and usefulness of geophysics for the scientific community and the public. I'm your host, Andrew Geary. Technological advancements in geophysical sensors and sensor platforms over the past decade have given rise to the rapidly growing and innovative field of drone-based geophysics. In this conversation, Dr. Callum Walter discusses the benefits of drone surveys when taking on dirty, dangerous, and demanding jobs. He highlights the similarities and differences compared to other geophysical surveys and the unique difficulties when collecting data by drones. Callum outlines a few case studies currently benefiting from drones, the possibility of rocket-powered drones, and using drones in off-world environments. Callum also offers when drones could be right for your project profile. This episode is a fascinating, cutting-edge conversation on the latest geophysical technology that could inspire and improve your current and future projects. Dr. Callum Walter is a postdoctoral research scientist with the USGS National Innovation Center and the NASA Ames Research Center, working on expanding off-world geophysical surveying capabilities to support NASA's upcoming crewed Artemis missions to the Moon, Mars, and possibly beyond. To read this month's special section in The Leading Edge, visit seg.org/podcast or check out the episode's show notes where you're listening. And now, my conversation with Callum Walter. Well, I'm excited to have you on, Callum, because we are talking about February's The Leading Edge that you worked on, and it focuses on drone geophysics. What are the elevator pitches for geophysicists and managers to utilize drone-based geophysics?
Yeah, so the elevator pitch I always tend to give is you need to think of this as an investment towards future geophysics capabilities. So for the majority of the time that geophysics has been around, we have kind of the standard set of geophysical surveys that we use to find things buried within the subsurface, whether this is minerals or UXOs or any of the other applications we have. But recently, we've had this new kind of platform technology that's come along that we're able to integrate with these geophysical methods and techniques. And this has just opened up a whole new avenue of research and capabilities that we're going towards the future. So I always give this pitch of you need to think about what's coming in the future. So I started this in 2016. We're now in 2023, and there's going to be a lot more interesting things that we're going to be starting to see leading up to the 2030s with drone geophysics.
I imagine this could be new for a lot of geophysicists and just scientists in general of how drones work. So what are a few use cases where drones are particularly beneficial for geophysical surveys?
Yeah, so the thing I always come back to is kind of the 3Ds, the dirty, dangerous, and demanding. It kind of goes hand in hand with robotics and how robots are kind of taking over jobs and stuff as well. But a lot of my experience was doing, hardcore field geophysics where you're running in the field with 30 pounds of geophysics equipment on your back, sometimes through swamps, sometimes in places where, there's mosquitoes everywhere. So it's not really a glamorous kind of, job. So what drones are able to do and where use cases are great with this is we can start taking people out of the field in these really kind of dirty or dangerous kind of places and start using drones instead. So there's kind of a push for that sense of it. Again, with dangerous, if we look at UXO detection, which one of the papers in this special issue touched on, it's a lot more advantageous to fly a drone over the surface relatively closely to be able to, even do a first pass in detecting these UXOs or unexploded ordnance. And it takes people out of this dangerous place where you have traditional minesweepers going with, EM, the classic, you see someone on the beach with them kind of looking along, trying to detect these things. So the other one that I'll kind of add to the classic 3Ds is kind of the data side of it. So we also can get some amazing data sets with drone geophysics once we kind of work past a lot of the hurdles that have come up with developing this. So I'll probably touch on this a little bit more, but definitely the data side is one of the main factors in driving this.
Yeah, we've got a lot of fun questions ahead, but let's focus in on those hurdles for a second there. So I think those 3Ds, that's wonderful. But what are maybe some unique difficulties that drones encounter when trying to get this amazing geophysical data for surveys?
Yeah, the main difficulty has been dealing with the interference that you have associated with drones. So a lot of the research that has gone into the last, say, 7 years or so has been looking at how to best integrate these sensors on the drone platforms, knowing that they're incredibly noisy in a lot of cases. So we can look at ways to compensate this data. We can look at ways to filter it out. We can look at ways to develop and integrate the sensors in a way that minimizes the noise from the drones. And when I'm talking about the noise of the drones, we're talking about the electromagnetic interference signals for the most part. So this includes a DC component as well as some higher frequency signals as well into the kilohertz range almost. So being able to understand these signals and filter them out or prevent them from interfering with the signals you're trying to sense within the subsurface is one of the major challenges that you need to overcome and be able to understand, be able to collect decent geophysics data sets.
It's much more technical, but I'm always amazed at how much similarities there are in recording audio to recording these surveys of dealing with signal to noise and DC current, just these things that we also deal with in recording audio. And let's look at that unexploded ordnance that you talked about. That was a paper by Tui and the co-authors. What did they discover when examining using drones for locating unexploded ordnances as their use case in their paper?
Yeah, so their use case was looking at kind of more of a remote sensing technique, so hyperspectral imaging and detecting unexploded ordnance that you might find situated on the surface. Now, some of the traditional sense has been looking for buried objects with this, and a lot of people tend to use GPR surveys for this. But one of the ways that we can augment the GPR surveys with drones to find the buried objects is also to use this hyperspectral imaging. One of the interesting things that they found that they didn't necessarily expect was that if you have a large enough drone and you're flying close to the surface, the wash of the blades can actually, displace any of the grass blades and things like that might obscure some of these objects. And you actually can get better signal from this to be able to detect using any of your AI algorithms that are being developed for this kind of automated detection in quick real time. So there's always something new to be learned. I say when you're doing these drone geophysics surveys.
Yeah, I have such an image growing up of my grandfather on beaches with metal detectors. I just imagine drones now flying flying around these beaches in the future. How does a towed unmanned aerial vehicle work?
Yeah, excellent question. So the main reason why we would put sensors underneath the drone in kind of a towed configuration is to get away from these, electromagnetic interference signals or any other sort of interference signals you might have coming from the drone. So typically what we do with this is we try and suspend it in a way that minimizes the motion of the sensor and the drone in flight. So typically suspending it from the center of mass and limiting, either the yaw, pitch, and roll and some of the specific axes. So certain researchers and industry professionals that work in drone geophysics, there's been a number of different techniques for this. You can use stinger mounts that have them kind of, rigidly fixed to the drone and then they extend out the front of them. There's some limitations and drawbacks to that. There's also kind of the method that I'm more familiar with and I've used through a lot of my research, which has been suspending it on a semi rigid mount to basically limit some of the rotations, but allowing some of the other rotations to be free so that it doesn't interfere so much with the drone as it flies. Because you have to keep in mind, the first time that we kind of flew these things and suspended a payload 3 to 5 meters below the drones, you're taking it off and you put it in the autonomous mode and you're going like a meter per second around the corner hoping the thing doesn't just flip over and fall out of the sky, right? So that's been an interesting thing to see. But I mean, I none of the surveys I've worked on, I've ever seen any issues with these suspended payloads. But it's definitely the first time people see them. It's pretty yeah, pretty nerve wracking.
Yeah, I feel like we need some photos to accompany this podcast so people can understand it.
Yeah.
Dosing and the co-authors, they conclude that it is possible using these towed UAVs that it could replace ground magnetic surveys. Why could this form of collecting data be better than what the current use of ground magnetic surveys are?
Yeah. So to kind of look at this and where drone geophysics is going to be going from a data perspective and how it compares to the traditional methods of both ground surveys or terrestrial surveys, as well as airborne surveys, where we have full aircraft collecting geophysics data. We got to look at both kind of the data resolution as well as the coverage capabilities, and then kind of the logistics of setting up these surveys. So, a lot of the work that I've done and the experience I've had has been conducted in the boreal forest. And if you've ever tried to walk around the boreal forest without cut lines, it's rather challenging to do any sort of geophysics with that. So, depending on the location, one of the challenges with ground geophysics is you have to put in cut lines. So, cut an area where you can run your survey in a straight line. Where geophysics conducted from a drone, while you're higher up and you maybe get a little less data resolution, you don't need these cut lines and therefore it's non-invasive. So there's kind of a component to this that it's a little bit more environmentally friendly because you don't have to go into these non-invasive areas. Now, from a data perspective, because you are flying typically a little bit higher than you would in the terrestrial surveys, there's a little bit of a data resolution drop. But a lot of times with the higher end sensors that we have now that we're being able to integrate with the drones, the data comparison between ground, drone geophysics surveys and then airborne is quite remarkable, and we see a lot more overlap with the drone geophysics and the ground surveys than we do with drone geophysics and kind of these higher altitude manned airborne surveys, both due to the data coverage ability, because drones can't really compete with the large areas that manned airborne surveys can conduct, but they can better compete with the data resolution with the terrestrial surveys. So you kind of have to look at the whole kind of package of how we run these surveys, the logistics, and drone geophysics can sometimes find these really sweet spots where we can, get amazing data and compete with the ground surveys.
Yeah, I like geophysics because there's just no black and white answer to so many things. It is a very complex. In audio editing, there have been a lot of recent developments in using AI to remove background noise, improve audio quality, and so forth. Is using AI machine learning to improve the data collection being used with drones?
Yeah, most definitely. And this is kind of the area that I'm most excited for coming into the future. So, where we've kind of come from, the past until now in 2016 is developing sensors onto the drones and showing that, we can collect good data with this. But the whole next kind of branch that we're going to be looking at is doing exactly what you said, applying AI to solve some really complex problems with both data processing, as the Cunningham paper looks at, where they apply AI to be able to filter out some of the compensation algorithm corrections that we need for drone surveys. But also, one of the interesting things that I'm hopefully going to be working on is doing edge computing with drones. And this is kind of the next big kind of topic. And edge computing is the ability for the drone to collect data, send it back to maybe a base station that we would have in the field, and link with the telemetry between that and process the data in real time to be able to inform where it needs to go next within the survey. So the traditional sense for geophysics, we have some sort of target within an area of interest within the subsurface. We blindly put out lines for the most part, other than we might know there's a strike in an area and we want to go perpendicular to that. We set out some sort of line spacing, and then we just go and collect the data throughout the day, maybe download it at the end of the day, try and quickly process it before we go to bed at night, and start the whole thing the next day just to see if the data quality is good and what's going on. With drones and the ability to put these high-end computers on them, we have the potential to be able to do this all in real time on board the platforms even, and then feed that back into the navigation system to be able to inform where it needs to go and survey in higher resolution, let's say. So it's going to be really interesting to see where all of this goes into the future. And I know there's a lot of bright scientists, researchers, and industry professionals that are all working on this.
Talk about real time. I mean, that would be incredible, I'm sure. You have a PhD in drone geophysics. I am sure you are on the forefront, and many more people are going to follow behind you. What are some use cases for drone geophysics that aren't represented in these four papers that particularly intrigue or excite you?
Yeah, so jumping from kind of my PhD with drone geophysics into more of the off-world geophysics environment that I'm working at here, one of the things that we're very interested in is kind of these edge compute cases, as well as moving into spaces where we can use drones in off-world environments. So there's a lot of interesting research going into this currently, but one of the things that I'm most excited about is the project I'm currently working on is using geophysics to look at kind of lunar resources and what we might be trying to find in the future there. Well, of course, on the moon, there's no air, so your traditional or atmosphere, so your traditional blades on the drone aren't going to work there. So of course, there may or may not be some developments in rocket powered drones that might be coming in the future. So of course, that's something very interesting to me. But I think even if we look towards, Mars and other things like that, the Ingenuity and Perseverance rover, they have both shown that we can fly on other worlds. There's also the Dragonfly mission that's going to be going to Titan. So there's a lot of use cases for drone geophysics as well as other sensors on drones in the more traditional remote sensing case that could be used in these off-world environments. And it's just going to be fascinating to see what data they bring back.
I kind of imagine that there's some drone making company out there making drones, and the geophysicists are figuring out how they can utilize what someone else is making who may not be even thinking about the geophysics use case. But is that wrong? Are geophysicists working with drone makers to kind of create the specs that they need to get the best data collection?
Yeah, that's an excellent point because in the beginning, almost everyone used off-the-shelf drones, and I mean they're not really tailored or optimized for drone geophysics specifically. But I think another kind of push is going to be for geophysics companies in particular to work with drone manufacturers as well as drone companies that have the ability to fly these routinely and work with them to be able to optimize the different system specs to reduce these noise levels and increase the data quality. So one of the challenges always with the geophysics companies coming at this is that they don't really have the biggest background in kind of drone operations or things like that, right? So they get this brand new shiny drone for a whole bunch of money, put their sensor on it, go up and fly it around, and if they're lucky and they don't crash it, the data they get back is usually, substandard from what they're used to. And it's kind of an off put. So, one of the ways that you can get around this is there is a huge body of research out there to date that has gone over a lot of the integration considerations, a lot of the data processing considerations, specifically for drones. And if you want to get into this, there's a lot of reading that you can do out there to kind of set you along the right path. Then, of course, partnering with the drone company is always a great idea too, because they bring their own expertise into the mix, and there's some good synergies that can happen there.
Yeah, a new form of multidisciplinary work in the world of geophysics now. As this discipline of drone geophysics continues to expand, what do you hope readers take away from these four papers? Maybe they're being exposed to drone geophysics, for the first time through this special section.
Yeah, my takeaway that I hope everyone has from this is that there's kind of a very large group of talented scientists, researchers, and engineers that are working hard to solve a lot of the issues that have been traditionally associated with drone geophysics. When I first started doing this and kind of presenting on the topic, there's a huge pushback from industry. The major geophysics players and things like that saying the data coming off of this is never going to work. You're just playing with the toy. Like, don't even bother trying to do this stuff compared to our systems that we've worked on for 25 years. And it's like, yes, I agree. Like the original, when systems you develop aren't going to be the best, but there has been a huge body of research that's been worked on and case studies that have shown that there's a lot of good use cases for this. Not now, drone geophysics is not going to be the be all end all of every kind of situation. You really have to look at your project profile, understand kind of the capabilities of drone geophysics, and see where these specific project profiles can fit into it.
Yeah, it's just not hard to imagine it being useful. I mean, when full waveform inversion happened, I mean, so much of that was theoretical until it wasn't anymore. And you could certainly see that here. So, if a geophysicist is getting excited about this topic, how would they get started in exploring drone geophysics?
I'd go back to kind of do your research sort of thing, read some papers on integration methodologies, see what sensors are available on the market and are compatible with the drones you might be looking at using in your fleet. I'd also say look at the project profiles you're working on and seeing if it fits with the capabilities of the drones. Because I mean, it's a really cool system and amazing, but if it's not going to work for your 10,000 line kilometer survey that you hope to fly in the boreal forest or something, maybe drone geophysics isn't quite the right platform for you. But there's a lot of other ways that you can kind of get involved and understand the space. There's a lot of kind of courses teaching people how to fly drones that you're going to have to be able to be compliant with, like the Part 107. And then also looking at thinking of partner with drone companies as well. They have the expertise with being able to fly these systems and probably a lot more expertise in integrating interesting sensors with them. But then the drone or the geophysics companies can then bring their expertise in the geophysics side and the physics side and be able to work and kind of partner with that. So that would be some of my recommendations on how to get into the drone geophysics space.
Is there something for a geophysicist that typically surprises them when they learn more about drone geophysics?
Yeah, I think the biggest one is probably just the flexibility in some of the surveying specs that you can come up with for it. So, I mean, you're working with almost a 3D space now where you can survey in. So, one of the interesting things with this is that you can do real time kind of sense and avoid. So, one of the interesting things that's going to be coming up is if you're trying to fly your sensor as low as possible, but you're in, say, a forested environment, you want to be basically skimming the treetops without kind of, getting your sensor caught in the tops of the trees. Well, some of the drones that will be coming out in the future have these real-time sense and avoid abilities to basically fly, a couple meters above the treetops. So that's just, I think the sensor capabilities as well as some of the other additional sensors you can put on with it is pretty amazing. The data sets that you can get from these very powerful kind of machines that we can fly around. So that's always a big surprise to a lot of the geophysicists, or to see their eyes pop when you show them some of the data sets that you can get back from these surveys.
And lastly here, Callum, what principle, teaching, or point of view has helped you succeed in your field?
Yeah, that's a great little piece of advice. I think my my piece of advice would be get interested in the topic that you're working on. So when I was going through undergrad, I thought I was going to be a chemical engineer. And I went into my first midterm and of course bombed it and then had to sit there and think, well, maybe I have to rethink what I want to do. And I had never heard of geology or anything to do with earth sciences up until this point, other than I was lucky enough to have one course in first year and I really liked it. So I was like, you know what? I'm interested in this. I'm going to kind of focus more on doing the earth science and geological engineering major. And I've never really looked back since then. I've always just kind of followed what has been of interest to me. And then, of course, when I went on to do the PhD and you get, pitched this idea of drone geophysics and developing this, I know I didn't think I was going to be able to top that as far as a topic to work on, but then lo and behold, I was able to, get in touch with the USGS and NASA to work on off-world geophysics. So everything I've done I've always followed something that's been very interesting to me and very motivating. And that, gets me coming into the office early in the morning and digging deep on these big questions. So try and find something motivating for you. That's my advice.
That's good advice there. Is there anything I should have asked that I did not?
Yeah, that's a really good question. Maybe just something to do with sensor integrations, like multiple sensors. A lot of people are starting, with the more heavy lift drones and things like this. They're starting to get, and the smaller sensors, you're able to put multiple geophysics sensors on a single drone and get multiple data sets, or collect LiDAR at the same time as you're doing your geophysics surveys. So there's some interesting applications with multi-sensor work that is hopefully going to be coming out as we develop more and more of these geophysics technologies.
Well, reading this special section of Leading Edge will be a great way to get started exploring the world of drone geophysics. I'm sure it's going to be featured again in the Leading Edge in years to come, and look forward to seeing what you discover in these off-world capabilities, and who knows what is next in this field. So thanks for your time, Callum.
Yeah, thank you very much. And I'd like to thank the SCG and the Leading Edge for reaching out to me to work on this. It's been a great experience all around, and a great conversation here with you, Andrew. So thank you very much.
You reached the end of Seismic Sound Off. Thank you for listening to this episode. If you want to be the first to know about the next episode, please follow or subscribe to the podcast wherever you listen to podcasts. Two of my favorites are Apple Podcasts and Spotify. If you have episode ideas, feedback for the show, or want to sponsor a future episode, visit seg.org/podcast and find the box titled Contact Seismic Sound Off. Zach Bridges created original music for this show. This episode was hosted, edited, and produced by me, Andrew Geary at Treasurement. The SEG podcast team is Jennifer Cobb, Kathy Gamble, and Allie McGinnis. Thank you for listening. This is Seismic Sound Off, signaling off.